Okay guys, welcome back. So in this will be probably the last video on friction. So in this video I will be talking about another complex problem in which there's friction between is very similar to the last problem. It's actually the last problem, but the only thing is that the total applied force, the applied force on the bottom object is now increased to a certain value. Alright, so let's take those two objects first. We'll draw those objects. The first object, this is the second object, and this is the plate. Right? So I'll take the mass of this object to be 5 kilograms, so its weight will be 5g here. This mass to be 10 kilograms, so its weight will be 10g down. Right? And there's no friction between the top and the bottom objects, but there's friction between the bottom object and the surface. I'll take the coefficient of friction as 0.2 as before. .2. So if I put a force of say 60 newtons, yeah, 60 newtons. If I put a force of 60 newtons, what happens to these two objects? Alright, let's find out. So if I put a force of 60 newtons, there is no friction between the top object and the bottom object. So what actually happens is that the only thing is that the top object now seems to be that it is impossible for this object to move. Alright. So for the bottom object, I'll take alright. First of all, I need to mark the normal forces, right? So the normal force, I'll take this object as A, this object as B. So the normal force on A, I'll take as RA, it will be like this, which is perpendicular to this surface, and RB like this, which is perpendicular to this surface, right? RA and RB. So okay, so the frictional force on B, there's no friction between A and B, so we can't draw any frictional forces on A. So the frictional force between B and the surface has been given, the coefficient of friction has been given as 0.2. So what actually happens is that if there's friction between B and the surface, and if we are putting force on this direction, the frictional force will be so as to oppose this motion and it will be acting in this direction. So the frictional force will be in this direction, which is Ff. Alright. So first of all, we have to find the value of Rb to find Ff. So I'll put F equals Ma for B in this direction. Right? So the force here is Rb, force downwards is 10g minus 5g, that is 15g, and the acceleration is 0. So Rb is equal to 15g, which is 150 newtons. I will take g as 10, 115 newtons. Alright? Okay. So Rb is equal to 150 newtons. So for B I can put Ff equals mu Rb. Right? So Ff is equal to mu equals 0.2, Rb is equal to 150. So Ff is equal to 1/5 to 150, which is 30 newtons. 30 newtons. So if I draw the free body diagram for B, considering only the vertical forces for B, right? So there will be a force of 60 newtons in this direction, and there will be a force of 30 newtons in this direction, right? So there is a net force now. There is a net force now. The total applied force is 60 newtons. Then the total opposing force is 30 newtons. So the net force is 30 newtons. Is acting in this direction, right? Net force. All right. So what actually we can do is we can put F equals Ma to this object. F equals Ma to this object. Right? So the total force is 60 minus 30, which is 30. The mass is 10 and the acceleration is A, so the acceleration of this object will be 3 meters per square second in this direction. And for A, there is no force that is acting on A, so A's acceleration will be 0. So B will move relative to A, and A will be stationary, but B will be moving this direction, and A will, what actually happens is if you are on earth, or if you are on the plane, on this plane, if you put a person on this plane, right, like this, if you put some person on this plane, what actually this person will experience is that A is going backwards and B is going forwards, and A will drop from here after some time, and B will continue its motion in this direction. So that is what happens when the total applied force is greater than the frictional force. Alright, so that will be probably the end of the videos on frictional forces. So see you next time with a new concept on mechanics.